Hello, I will explain the code for past task 8. So this is the explanation. This is a linear equation y equals to ax, and we have to solve it using LU decomposition along with the backward and forward substitution. So we have used the NumPy library to handle matrix operations. Then we have defined the LU decomposition function. It takes the matrix A as input. It is the coefficient matrix from the system, like Ax equals to y. We initialize two matrices, L, which is a lower triangle, and U, which is an upper triangle, and as a zero matrix of the same size as the A matrix. The first loop will go through each row of the matrix. We set the diagonal elements of L to 1 because it's a standard property of the LU decomposition. Then the second loop calculates the elements of U, and the third calculates the element of L using the LU decomposition formula. The function will return the matrices L and U. Then this is the forward substitution function. Once we receive the lower triangle matrix, we solve the intermediate system, which is Lz equals to y, using forward substitution. The subfunction solves for z, which is an intermediate vector. In this each iteration of the loop, we will calculate z of I based on the values from the matrix L and the right hand side vector y, and we will receive the vector z by this function. Then its backward substitution function. After solving Lz equals to y, we need to solve ux equals to z by using backward substitution. This step finds the solution vector x. This function starts from the last row of u and works its way upwards. Because u is a upper triangular, so we use backward substitution. In each iteration, we will calculate x of I using the formula. This function will return the vector x, which will be the solution of the original system y equals to ax. And later on, we define a matrix A and vector y representing the system y equals to ax. We use the LU decomposition function to get the matrices L and U, and then we perform forward substitution and backward substitution. The final result is printed showing the solution vector of x. So this is a very simple code which I have coded in Anaconda, and this is what the solution I got: 1, 1 and 2, which is the accurate solution. I have just tried it with um, theoretical basis as well. And coming to this thing, it's all written in here. So we need to maximize z equals to 18x1 plus 12.5x2, and it's subject to um few calculations. So first step is to equalize it and get a linear equality function, and then we can set up the initial simplex table as well. This is the initial tableau, this thing, and then we identify the pivot column, So we can determine it by which variable to bring into the basis, find the most negative value in the bottom row. So the objective function row, which is the z, this thing, which is negative 18 for x1, and hence we take those values and we get the optimal solution, which is x1 equals to 12 and x2 equals to 8, and then putting it in the equation we get the value, the maximum value of z, which is 316, and is the final answer.